This is a test of 41990. We have an unusual problem in the logic area that switches the inputs. And I'm going to show you, Scott, a workaround, but I'm not going to be satisfied with this. I'm going to look for some of the chips that handle this anyways, but I just want to show you where we are. First of all, everything's been done. Switches, controls, both output boards been rebuilt. Everything that was in the estimate has been done. Tuner's been aligned, has an incredibly sensitive tuner, but we do have this logic problem. So first of all, I'm going to show you what we're going to be looking at here. Is I keep the light down because this camera gets saturated, but this is obviously your unit, and I'm just going to show you. Where's the zoom with this here? This device with the two horizontal lines. It's a dual trace oscilloscope. The upper trace is going to show your left channel. The lower trace is your right. As we're viewing this to the left of the dual trace oscilloscope, there's two frequency counters. That's what those two sets of rows of horizontal numbers are. They're not going to be relevant for this testing. But immediately above that, you'll see two little dots. That is a bar graph that's calibrated in decibels, so we can actually see any differences in the channels rather than squinting at the oscilloscope. That device is actually in parallel with the output of the oscilloscope, and they're going to change as the oscilloscope changes. Okay, so I'm going to back this out a little bit. Now I'm going to show you what it's supposed to look like. Then I'm going to purposely screw it up and show you how we can work around, but I'm still not satisfied. I'm going to look for the chips, but I do want to show you where we are because I put a lot of time into this, and it's nice, but we have this problem, so how nice can it be? So anyways, I'm going to turn this up, and what we're going to see, and we're going to be able to hear it too, but on this microphone, you're not going to be able to hear separation like you would with speakers. So again, I'm going to take the balance, and I've just taken the balance control, and only the left channel is playing. That's the upper display on the oscilloscope and the horizontal bar graph. Now I'm taking the balance and I'm going to the right. And all the switch controls now have been deoxidized. The signal is rock solid. I can bang on this and nothing happens. I'm going to show you a frequency response test. We're going to step through. And what you can do is watch the bar graph here as I'm trying to point at this. So as I go through the different frequencies, it's not going to change. You will see the period displayed on the oscilloscope change because the frequency is changing, and this microphone is not going to pick up the extremely low frequencies or any of the frequencies, maybe above 10K or so. But that's what the oscilloscope is for. Okay, so we're going to go, let's just start at the very bottom here. And so what we want is we don't want any appreciable change in the oscilloscope pattern and the horizontal graph. So let's go down to that is about 20 hertz. I'm trying to see what it says on the signal generator. And again, you know what I'm going to do? I'm going to actually zero in on look at all those toys, huh? I have a good time at work. I'll actually zero in so we can get a better view of, you know, one of these days stereo surgeons will be able to afford a camera person, but right now this is a low budget operation. Okay, so that's about, let me actually tell you what it is. Let me look at this. That is 20 hertz. What a good guess. Okay, so we're going to step this up, and you'll see the oscilloscope change, and when we get into the range of the microphone, you'll actually hear it. But that's about 40. I think that's like 63. All right, this microphone's going to probably lose its high frequency response as we go up. So right now we're up into the range of dogs and bats. All right, but so frequency response wise, it's right on the money. You can drive this to full power, and the way I'm going to do that is flick the speakers off as we increase the power. We don't want to hurt my ears or our speakers. And we're just switched in what's called dummy loads. Dummy loads put the same amount of stress on the amplifier as does the speaker, but it takes the audio energy and converts it to heat. Now I'm also going to have to change the gain on this so we can get more of a range on the scope as we increase the volume. Okay, so I'm going to increase the volume. Well, we need more. We need more. And right now, we are driving 8 ohms, but still have beautiful sine waves on the scope. And let's see how far we can go before we start to square wave. We need. Right now, this would be causing blood to come out of one's ears. There you go. Whoa, we don't want to go past that point. Right about there is where we're driving both channels into saturation. Very high current draw. But the item is, audio-wise, it's great. Tuner-wise, it's great. I'm not happy with what's going on with the switching, so I'm going to order some chips and continue the saga. This is turning into my life's work. Anyways, I'm going to save this video, upload it, and then send you the link and give you a follow-up phone call. Then I'm going to put your other item on the bench, and we'll see what we find.